This started off as just scrapping a capacitor from an AC equipment. One that was changed out, obviously, has not good anymore. And it transformed a little bit further also in understanding what all those ratings were. Um, didn't really ever consider some of the other things that's written on the capacitor, and I'll spend some time up front now just describing what I've come across. It's interesting that this is not easy to combine in one source, so yeah, it does make a little bit of effort involved. So if we look at the capacitor now, you'll see 435 microfarads, 270 volts AC on the top. The 435 requires two different capacitors in here with a common. The 4 capacitors is 4 microfarads for the starting of the fan. The 35 microfarads is for the starting of the compressor, and 270 volts AC is the rating of the capacitor, the voltage rating. So that basically says that this is a single phase capacitor meant for a single phase system in a 110 115 volt system, which will be root 2 times that maximum voltage. I think it's 180 something, 185 thereabouts. Below that, the next line says plus or minus 5%. Well, that's obvious. Plus or minus 5% of the ratings above is what the value should come in when you test it. 50-60 hertz, which means it operates on both systems. Interesting though, because most 50 hertz systems tend to be 230, 240, 220. Any of them wouldn't work at 270 volts AC. The highest voltage on the system is closer, well, it tends to have capacitors at the 400 volt rating and be root 2 by the 220, 230, 240, so it's going to be significantly higher, about 1.42 somewhere. Think about that. The next line has the capacitor's model number. Fair enough. SH on the following line means self-healing, sorry. Protected dB I have not been able to figure out. HPF, high pass filter. MS, I'm not sure what that is. 10,000 AFC. Interestingly, that's not that easy to come by information. That is not easy to come by also, and that really comes up to be the available fault current rating. These capacitors are theoretically capable of interrupting fault currents up to 10,000 amperes. I guess it depends on the voltage. I probably wouldn't trust my life on 10,000 ampere rating capacitors. Class A on the capacitor tells you basically what is the rated hours it works at. Class A apparently is 30,000 hours, Class B is 10,000, Class C 3,000, Class D 1,000. So this is supposedly rated at 30,000 hours operational. And the P2, alright, basically that's the protection level that the capacitor offers, and basically PO means no protection. P1, it could feel open or it could feel shorted. P2, it's supposed to feel open circuit alone, which obviously makes no sense. And then the name of the company, Samwa Capacitor Company. Googling this, it comes from Korea. Well, I would assume it's South Korea and not North Korea, since nobody really deals with North Korea. So basically, yeah, that's where we are with in terms of the capacitors information. Now moving forward on that, what we have is picture showing the top of the capacitor, and that has essentially the contacts, the 3 contacts that we discussed. I'm not sure if it's easy to see, but the one with 4 will most likely be the common, and the 3 is probably the compressor, and the 2 is probably the fan. I can't remember, I've thrown away that cap. This was actually shot about 8 or 9 months ago. The other picture that we get into shows when you take off the cap, and the wrong side of the cap. What I've done is flipped it. That's the wrong side of it, and shows how it connects inside. And the other picture after this, now it's coming up, this one is it shown sideways. It's the same cap. That's what they do. They basically rivet it, and they have pins sticking out, and those touch down, and they touch down into the capacitor body and make contact in the relevant areas as shown here. And that is really a rubber seal. Underneath of that, you have the three metal contacts that you saw above. They're going through. There's a ton of grease inside of this thing. I suspect it's probably a silicone based type grease, but really there's no way for me to test this, so I'm just guessing that really. It's a lot of grease. The capacitor itself is actually inside of a plastic housing. That took a little bit of doing to get out because that is pretty tightly pressed inside there. So it is definitely isolated 100%, I would say, from the external casing, which is, well, an unfinished, unpainted aluminum, housing. It's probably going to be quite conductive, so I guess it makes sense to have that and ensure that there's no possibility of any of the internal windings of the the conductor and dielectrics would ever touch. Obviously the conductor is a problem. This is a picture of the inside now of the, when you pull that out of the plastic container we just looked at, and as you could see it has a bit of insulation. If I recall correctly, it was a winding of dielectric and the conductive thing, and if you notice there's a sort of a damaged spot there, and that really is probably a failure point on this device. This is another view of the bottom. This is a sort of cast metal they use on the bottom. It's like a big washer, and it's really brittle. I'm not sure. I don't even think it's zinc. I'm not sure how they did this, but it's a brittle material. It's falling apart just getting it out. So I guess it probably works as a compress something. I don't know if it's sintered. I guess it works if it's pressed inside the case and there's nothing to interrupt it, to forces to cause it to start a crack. But when you pull it out, as you can see, cracks are starting to form, and this is just another shot of the same thing. So basically ran through what you can expect to find on a start capacitor for an AC unit. Some of the ratings, there are a few more ratings. This one doesn't have more, but there's things that will tell you what the dielectric is, what the, basically a little bit more information on the dielectric, the oils or anything else in there. But this is still quite a bit of information to really understand what these things are telling you, and it's something I never took the time before to look into, and having done this, I think it was quite useful to really understand what goes on a little bit more, just a little bit more. Maybe another day I'll get a little bit more again. If I've missed anything and anyone knows, please feel free to correct me. And if anyone knows what the protected dB is or the MS is, I would definitely like to know.